Welcome back to the Knowledge Equity Partners channel. In our first episode, we looked at why governments and critical enterprises cannot rely on renting intelligence. When you send your sensitive operational data into generic cloud APIs, you lose visibility and control over where those packets scatter across a public network. Today, we are examining the direct alternative, the Palantir NVIDIA Sovereign AI Operating System, a comprehensive blueprint for building an AI factory. By integrating the data center design, the software stack, and an open model ecosystem into one validated package, organizations can deploy secure artificial intelligence immediately without having to assemble the pieces through trial and error. To understand how this works, we have to start at the physical bedrock. True sovereignty means you control the actual physical hardware running your workloads, locked safely inside your own facilities. At the foundation of this specific stack are NVIDIA Blackwell Ultra systems. Each node contains 8 Blackwell Ultra GPUs, all tied together with Spectrum-X Ethernet networking, designed exclusively to handle massive training and inference pipelines. These components form what NVIDIA calls an enterprise reference architecture, a pre-validated end-to-end data center design that integrates every layer of the compute stack. NVIDIA rigorously tests these specific configurations of GPUs, storage, and networking, so they deliver predictable performance. When a critical agency runs an intense AI workload, the infrastructure operates exactly as expected, right out of the box. Buying chips is easy. Sovereignty requires owning a tested production-grade pattern for how those chips interact under intense demand. Once that hardware foundation is laid, Palantir brings its full software suite to sit directly on top of the NVIDIA stack. The first layer is Palantir Foundry. Organizations generate raw, fragmented data across sensors, system logs, and transactional databases. Foundry ingests these disparate streams and cleans them into usable formats. From there, the data enters the ontology layer. As this diagram illustrates, flat tables of cleaned data are transformed into an interconnected map. Abstract data points become defined assets, threats, and physical infrastructure. This graph acts as a strict, structured map that directly mirrors the organization's unique operational reality. You never want to prompt a language model directly on raw spreadsheets or logs. By forcing the AI to interface strictly through this governed ontology, its outputs remain auditable and anchored to real-world parameters. Moving up the stack, we reach Palantir AIP, the artificial intelligence platform. Think of AIP as the harness that securely connects the underlying ontology to the AI models themselves. AIP enforces structured workflows and strict access controls. It prevents the AI from acting outside its authorized permissions or hallucinating solutions that defy the established rules. To manage this complex software across a vast organization, Palantir uses Apollo. Looking at this network map, you can see how Apollo acts as an autonomous deployment mechanism. It pushes synchronized updates, handles versioning, and monitors system health across central data centers, remote edge locations, and classified nodes, all without breaking security protocols or requiring manual intervention. Together, AIP and Apollo ensure that hundreds of isolated servers function safely and scale as a single coherent operating system. Finally, we reach the intelligence layer itself, NVIDIA's family of Nematron models. Nematron is published under an open model license. The weights, datasets, and training recipes are fully accessible to the organization using them. Palantir's Nematron engine takes these open models and deploys them securely inside the operating system, linking them directly into the AIP harness. When an agency relies on a closed API, they rent a black box. Open weights let them inspect the underlying math, adapt training recipes, and own customized derivatives in-house. When all these layers are stacked together, a new capability emerges. As this flowchart shows, every piece of telemetry and mission outcome is fed back into the foundation. This operational data continuously acts as a post-training signal to fine-tune Nematron for specific missions. The result is a sovereign AI stack that creates its own self-improving intelligence. It grows increasingly specialized to your enterprise every day, without ever leaking a single byte of data to the outside world. In our next episode, we will compare this self-contained stack directly against closed frontier language models and break down exactly how enterprises decide which workloads require true sovereignty. Subscribe to follow the rest of the series.